Welcome everyone. Thank you for joining us for today's FiberTalk webinar. I'm here with Safi Alam from Ftth Council Asia Pacific. I hope everyone is doing fine in this second, third, or fourth wave kind of thing. So today our webinar topic is innovative FTTH network migration solutions from DSL to FTTH for MDUs. So participants attending this webinar would have a chance to walk through the utilization of engineering and planning software, which is FiberPass from ibwave, and clear track solution from Corning to design and implement FTTH solution in MDU environment. So we have joined by three gentlemen today with me. One is Ariel Soli, another one is Justine, and the third speaker for today is Carl from ibwave. Justine and Carl both are from ibwave. So our first part of the presentation will be presented by Ariel to just give you a bit about Ariel. Ariel is the application engineer supporting Corning optical communications in Southeast Asia region. More than 12 years in telecommunications industry with experience in copper and fiber for carrier and enterprise networks. He has been actively involved in numerous FTTH projects with major telecom companies in region. He is based in Philippines and looking after their operation there as well. So before I hand over to Ariel, for all the audience, we will have a Q&A session at the end. So if you have any queries or question in any point of the presentation, so you just do not hesitate to type those questions or queries in the question panel in the platform. So we will definitely try our best to discuss that with the speakers. So with this, now I'm handing over to Ariel. Please welcome Ariel.
So can you see my screen now?
Not yet.
How about this one?
Not yet.
Wow, what happened? I already click.
Okay. Just
yeah.
Resetting this. Just
Okay.
give me a...
You should have the presenter mode.
Yeah. So can you just check now, Ariel?
Okay. I'm already showing my screen. Can you see now?
Not yet.
Okay, about this one, yeah.
Yes.
It should be right. Okay, thank you. Okay, so good morning, good afternoon, and good evening, everyone. So I'm Ariel Soli. So I'm from Corning Optical Communications, Application Engineering. So we'll be discussing innovative network migration solution that is coming from a copper broadband to a fiber broadband, which is FTTH, in a multi-dwelling unit setup. So with me actually is Justin and Carl. So they will be my co-presenter, and later on they will be actually presenting about innovative engineering and software and planning software. Okay, so let me start. So FTTH has been actually aggressively being deployed by telcos for the past 20 to 25 years, and yet there's still a lot of subscriber connected to a copper broadband, which is mainly DSL, then especially in a multi-dwelling unit setup. So people or customers actually no longer view access to high-speed broadband as a nice-to-have feature in their homes today. It is actually an essential service and becoming a basic necessity. Using fiber as the medium to deliver high-speed broadband dramatically increases the connection speeds and thus the customer experience of users. So as we know, fiber optics have a clear advantages over copper. So from having a low attenuation wherein a copper is losing about 94% of signal over over 100 meters versus fiber which is at 3%. And of course, to having a virtually immune to crosstalk, which is copper is very prone to. And of course, for security reason, it is almost impossible to tap a fiber. And with this, deploying FTTH or fiber infrastructure by our service provider brings more to the table than actually just lowering the operating costs. It efficiently positions themselves for a long-term success. So that is why copper broadband or DSL connection is in decline and fiber broadband is on the rise globally. So customers expect seamless, fast, and reliable connectivity. Fiber optics are greatly improving the speed of commercial networks, and now residential is also demanding, meaning they also require a higher bandwidth application solution. So especially now that during this pandemic, more are actually encouraged not to go out and work from home. And like the case here in the Philippines, students actually are required to study online uh, from, uh, from, from their homes. So to meet this demand, our service provider actually are quickly expanding their networks uh, to bring fiber connectivity into a traditional residential homes. So either a single family unit or a multi-dwelling unit. But in terms of economies of scale, deploying FTTH in a multi-dwelling unit setup is more cost-effective, okay, than in a single family unit. So there's no need to pull kilometers of cable just to reach a subscriber. Environment also is somehow more controlled, wherein we can actually avoid work stoppage due to extreme environmental conditions. And of course, there are millions of multi-dwelling units or buildings worldwide and are occupied by the third of the global population. In metropolis or in cities, almost 30 to 50% lives in a multi-dwelling unit. It can be more, especially in a highly densely or highly concentrated population. So, but how how do we migrate these buildings from copper broadband to a fiber broadband efficiently and faster? But prior to that, let us first identify the following: the deployment options as well as the challenges being encountered by our service provider now, especially in this brownfield multi-dwelling unit. So there are three options in deploying fiber. Okay, so fiber to the basement, fiber to the hallway, as well as fiber to the living unit. So in the race for a multi-dwelling unit uh, for MDU subscriber, actually service providers have chosen to take fiber all the way into the living unit for various business reasons. So it provides greater bandwidth as well as a better customer experience comparing to the fiber to the hallway as well as fiber to the basement. It also avoids the often complicated problem of finding space in the building for a shared 19-inch rack-mounted optical network terminal. And it can be more cost-effective because individual ONTs are only deployed as individual subscribers sign up for services. In addition, the cost to power the optical network terminal is paid directly by the consumer rather than the building owner as compared with the shared rack-mounted optical network terminal. So deploying FTTH in MDUs is full with its own set of challenges such as no one-size-fits-all solution, congested docks, lack of pathways, aesthetics, and of course, tenant disruption. In a brownfield MDU in particular, size matter. By their very nature, MDUs are comprised of compact living spaces where bulky hardware eats up space and stand out visually Moreover, the architectural design of NDUs produces apartment layouts with many corners and turns, further compounding the issue of running fiber cable through the home without compromising signal performance. So multi-dwelling units comes in all shapes and sizes, ranging from high-rise building, medium-rise building, low-rise building, small condominiums, or multi-use properties with a combination of a business and residential customers. So with this, no two MDUs are exactly the same in appearance or construction, nor are the solution for one going to fit into others. So each building needed to be treated and approached differently. Some would be small MDU, which is composed of 2 to 3 floors that have up to 12 living units. Some would be a medium multi-dwelling unit, which is composed of 4 to 6 floors with up to 72 living units. And some would be large MDU, like a high-rise condominium, hotel, and so on, which is actually 7 floors above and more than 72 living units. To add on, most of these buildings were constructed before FTTH or fiber networks were thought of or introduced. Okay, they were not designed to accommodate or route a standard fiber cable. So the expansion of residential fiber networks poses several installation challenges, from navigating cable around structural obstacles to unsightly installations. While residential consumers are pleased with the new options for better connectivity, they are often displeased with the unappealing footprint left by fiber cable routing. So despite the several advancements in FTTH technology, service providers deploying FTTH in MDU still face the challenges of running fiber cable from the hallway node into the living unit. So traditionally, in older buildings, pathway for routing cables in hallways didn't exist or were too congested with existing wiring, and new ones has to be constructed. These pathways were often bulky, expensive, and craft sensitive, such as crown moldings or plastic raceways. Once the pathways were built, drops, drop cable were placed by pulling or pushing one at a time to complete the installation process. So typical drop, so additional, actually, there additional options inside the apartment unit or even in the hallway were ruggedized drop cables. Okay, so they are often stapled along the ceilings, door frames, and as well as baseboard. In addition to being unsightly to many tenants, the long-term viability of this method for deploying drop cables is up for debate. Okay, some manufacturers say careful stapling using a rounded rounded crown staple does not damage the fiber. Actually, other advise against stapling altogether. Okay. Moreover, in some situations such as concrete walls and floors, stapling is simply mechanically impossible. Okay, so property managers, unit owners, building admin would always want the high-speed quality broadband being offered by fiber or FTTH, but most of them do not want disruption. Just needed to have a to have a connection. So typical offerings may be expensive, time-consuming, and disruptive to tenants. Because of these following tools needed to complete it, such as staples, circular, so hammers, nails, and clips to be able to install the crown moldings, plastic raceways, or even the stapling of the ruggedized drop cable. Okay, so to address these issues and concerns, some manufacturers came up with another solution. It involves using a bare 900 micron fiber with bend control corner hardware. So in this design, the fiber is routed along the baseboard, wall, or ceiling and feeds into bend control corner accessories for protection around angular obstacles, such as inner or exterior corners. So one of the pitfalls for this setup is it requires securing the fiber in place with a fluid adhesive, or what we call is a glue, a process that is both time time and labor intensive. The skill of the installer is very important because it's possible to introduce microbends to the cables, compromising the signal and causing damage to the property. Other cable manufacturers have developed a adhesive coated bend insensitive single mode fiber, which actually would require a heat gun or an applicator. Okay, it's the same case. If the installer find it's too hard to use it, they will end up uh, uh, end up with the same messy installation as shown on the photo on the right. Okay. Okay. Okay, so given all these challenges, concerns, and issues of deploying a fiber or migrating DSL to FTTH to for a brownfield multi-dwelling unit, how can service provider make their installation fast and easy and keep the property managers, building administrator, or unit owners happy? So allow us now to discuss these two innovative solutions. So first, I will be discussing the DC pathway with fiber solution, with which I will then later on, Carl and Justin will be discussing the engineering and planning software. Okay. So several solutions, as discussed a while ago, several solutions meet the requirement of expanding the residential fiber network. Okay, but they're falling short on statics or fast installation process. Customers aren't always satisfied with how an installation looks. Craftsmanship is highly variable among installers, and customers too are not satisfied with how long the installation a job takes. Okay. As a result, service providers struggle with the consistency and installation quality as well as customer satisfaction. So table shows comparison of different surfaces. Okay, so on in living unit application, so we have crown moldings with drop cable, plastic cable with raceways, uh, plastic cable raceway with drop cable and stapling glue with 900 micron fiber, and so on. So on the first column, actually, are set of parameters such as ease of installation, single core installation time, as well as aesthetics. It is clear from this table that there is really a need for a better solution. So with this, the new solution actually is an adhesive pathway with fiber that will address the ease of installation and will be able to be installed by a single crew without sacrificing the installation time and, more importantly, the aesthetics. So allow me to discuss its technology. So we at Corning developed actually a comprehensive approach to address these multiple concerns for horizontal cabling of FTTH by service providers, developers, as well as unit owners. So we have what we call is a clear track fiber pathway solution that is composed of a horizontal pathway and a drop cable. So we have a clear track fiber pathway for in living unit or inside the home. And the other one is a clear track hallway fiber with 12 fiber micro module. So application is for the hallway. So these comprehensive solutions offer high-speed broadband solution that is aesthetically pleasing, minimally intrusive, and simple to deploy. In fact, actually, residents hardly know it as it leaves an invisible footprint. So why or how footprint can become invisible? So clear track fiber pathway diffuses reflected light, resulting in near invisibility. So the technology behind clear track is its micro-replicated features, which allows diffuse reflections. So when light hits the surface, it scattered in many angles, making the clear cable pathway almost disappear. Okay. Then the clear translucent tape adhesive back pathway is delivered actually on a spool with a protective red liner backing. So when installed, it is clear, flexible, and has a small footprint without any visible seams. So it installed directly onto a wall surface using the pre-attached tape adhesive without the use of a raceway, a conduit, or a duct. The adhesive backing is meant to be for permanent bonding. Okay, so be careful. So one it stick, actually it stays. So going back to no one size fit all solution, uh, by our service provider, ClearTrack Fiber Pathway would be able to address most of this. It simplified the engineering processes from determining and planning the cable route during the site survey to creating the bill of materials. So this, since this is a surface mounted pathway, you just need to determine the optimal cable routing, and there you go. Okay. So, and comparing this to traditional and other options of horizontal cabling installations, there is no need to cut the drywall, or worst case, if the wall is a concrete wall, a rip and repair method is done just to install a duct or conduit, or just pulling or pushing a cable. So if homeowners or developers allows you to use surface mount solutions such as installation of plastic raceways because they don't want their wall surface to be damaged, you will end up cutting, drilling on site to install it. And in most cases, you will have unsightly raceways along the corridor or inside the unit. If homeowners or developers are not so sensitive, pulling and stapling a drop cable is an option, but this can end up with unsightly appearance too, and is not applicable to concrete surfaces. Using liquid adhesive or glue is also an option, but this usually takes a long time to complete and appearance would not be consistent. So using ClearTrack with adhesive backing enables fast and easy installation. There is no need to cut the drywall or use unsightly raceway staples and glue. Just peel back the protective liner, stick, and press it. So property managers, unit owners, building admins would always want the, as mentioned, would always want the high-speed broadband being offered by a fiber, but most of them do not want disruption and that it might bring. So simplifying the process, minimizing the bill of materials, and avoiding the equipment tools needed like circular saw, hand drill, hammers, stapling, and adhesive applicator reduces installation time and noise that creates disruption to the tenants, especially in a compact living spaces like a multi-dwelling unit. So because of a tape-like adhesive is used to mount the fiber pathway to the wall, installation is less disruptive than traditional methods such as stapling. The pre-attached adhesive backing of the fiber pathway has been engineered for compatibility with a broad range of indoor wall surfaces, such as sealed concrete, sealed or painted brick, flat wallpaper, as well as painted drywall. And ClearTalk Fiber Pathway has two rows of flexible and mushroom-like features with precise lengthwise separation that form actually a track. Through diffuse reflection, the contours of these features create the pathway's low visual profile, while their precise pitch hold the fiber in place. So from the illustration below, you can see that the cross-section of the ClearTalk fiber pathway at the bottom is a tape red liner. Then the next layer is the adhesive. Then on the top layer, actually the two mushroom-like feature which hold the fiber in place, not too tight and not too loose, just enough to keep the fiber in place and hold into position. So aside from simplifying the engineering process, ClearTalk Fiber Pathway solution simplified the installation process. It has a simple installation tools that helps installers maintain actually consistent spacing from the ceiling or a baseboard, or prevent uneven rounded corners, as well as applying enough pressure to the adhesive. So the handheld installation tool with the blue wheels actually is for the hallway, while the white one is for the in-living unit application. And one of the great advantage of using ClearTrack hallway fiber pathway with 12 fiber micro module actually is enabling installer to install it in hours and not in days. Okay, so the clear translucent tape adhesive back pathway is delivered on spool, so you can just cut according to the actual length during installation using either a scissor or a snips. So, and then the 12 fiber micro module actually can come pre-terminated or unterminated, as well as for the 900 micron cable. So let me discuss to you the process for the hallway solution. So as the ClearTalk hallway fiber pathway solutions have only two main components, which is the adhesive back pathway and the 12 fiber micro module. The micro module is already protected by the pathway itself since it's inside. But if additional protection is needed, the solution has optional accessory called clear cover. Although ClearTalk fiber pathway hallway is handling 12 fiber micromodule, look at its small dimension. It is only about 3.8 mm by 4.5 mm. Then the 12 fiber micromodule actually is using 12 ultra bend insensitive fiber in a 1.8 mm jacket. Conventional fiber optic cable can withstand a minimum bending radius of 30 mm. Roughly speaking, it can be bent around a soda can at its best. So any tighter bend and it begins to experience unacceptable levels of attenuation. In a MDU with multiple sharp corner and tight spaces, installing fiber cable within the acceptable bending radius often proves difficult. Okay, leading to scenario: the cable cannot be installed flush to the wall, or it creates a service complaints. And bend insensitive fiber cable has found its true calling actually in a multi-dwelling unit. The ability of bend insensitive fiber to hug actually the wall around the multiple sharp corners found in apartments as well as in condominiums has significantly increased the aesthetic appeal of FTTH deployment in a MDU. It also saves cost in terms of installation time and reducing the occurrence of damaged cable and service interruption. So based on observation, cables being bent through a 90 degree through a 90-degree corner and around obstacles were found to be a typically imparting actually 5 mm bending radius. This is particularly evident in miniaturized cables such as micromodule. So to address this issue, the ClearTalk hallway is using as mentioned, a ultra bend sensitive fiber, which is G657B3 and a bending radius of 5 mm. Together with the ClearTalk hallway, it allows insulation that seamlessly hug the corners without additional accessories. To have a demarcation point between the hallway and living unit, a small point of entry box is installed along the corridors or hallways just outside the rooms or units. In this is actually in this small point of entry box, you can terminate, you can do splicing, you can do field mount connectorization, either and so on. Okay, so it will serve as a demarcation between the hallway as well as the in-living unit. So how does it be installed? So this is the typical installation diagram. Okay. So after identifying actually the cable route, ClearTalk hallway will be installed by removing the red tape liner and sticking it on the wall. Okay. After that, the 12 fiber micro module actually will be inserted on the ClearTalk fiber pathway. Then each unit will have its own point of entry box. Then afterwards, we can do the field mount. We can do the termination, either fusion or field mount connector. So from the POE as well as on the fiber distribution panel. Okay. So let me show you some installation photos as well as a short video. So currently, the ClearTalk fiber pathway hallway is being installed using as mentioned, the simple installation tool. Then now, the process now is actually installing the 12 fiber micro module into the ClearTalk fiber ClearTalk hallway fiber pathway. Then, as mentioned, every unit will have its own small point of entry box, or what we call as a demarcation box. All right. Okay, so with this, so I would like to show you some actual installation photos. So as you can see, it is really very neat. Uh, uh, it's really very neat, as well as it respects the static requirement of each building. Okay. Okay, so these are some of our installation video, actual installation photos. Okay, so now that we have cleared the hallway using clear track hallway fiber pathway with 12 fiber micro module, let us proceed now actually inside the unit. So clear track fiber pathway for inside living unit is using the same technology. Okay, it's just that it is now designed to handle single fiber. Okay, so same cross section, so same component. There's a protective liner at the bottom. Then the second layer is the adhesive. Then the next layer actually is the two mushroom-like feature that holds the fiber. The difference now is on the fiber. So now it's using 900 clear fiber instead of a 12 fiber micro module, and the dimension actually was reduced slightly. So 3.8 to 3.7. Okay, so this is also a typical installation diagram for the clear track in living unit. So after actually, if a subscriber uh, application is approved, installer actually will go to the building and assign floor as well as to the assigned unit. So he will check first the proper cable routing. Then afterwards, he will need to actually drill an access if it's not yet available, then cover it with a micro point of entry box, which actually will conceal the drill hole or drill access. Afterwards, there will be a clear track. We can actually install the clear track ILU by removing the red tape liner. Then we can now actually insert the 900 clear fiber into the clear track ILU, going into the small POE box and up to actually the wall outlet. Then afterwards, we can again we can do termination either fusion splicing or using a field mount connector such as the NPC Plus. Okay, so to actually conclude my presentation, ClearTalk Fiber Pathways enable service provider to deliver virtually invisible high-speed broadband connectivity uh, uh, either for greenfield or brownfield multi-dwelling unit. So the solution actually are smart, stylish, okay, as you can see based on the actual installation photo. Its installation is also fast and easy. In fact, one person can do the job alone and not in days but in hours. So with minimal noise and intrusion. So the advantage actually are clear. So it is clearly faster, it is clearly easier, and it is clearly better in providing invisible footprint in actually a fiber to the home deployment. So I will now turn over the presentation to Rusafet to actually introduce the next speaker. Thank you.
Thank you, Ariel. It was a nice presentation. So I will now hand over to Carl and Justin. So about Carl's background, he's the regional sales manager at ibwave. He's working in ibwave since 2014. He has 24 years of experience in fiber technology, testing measurement instruments, and some fiber projects in Philippines. So he's based in Philippines right now. And Justin Saw, he is the senior solution engineer based in Singapore at ibwave. He is in the industry for 14 years. He has past experience as a past experience. He worked in Huawei in wireless networks basically. in 3G, 4G, and 5G networks. And since 2020, he is with ibwave. So I will now hand over to Justin Saw for his and Carl's presentation. Please welcome Carl and Justin.
Thank you very much, Giuseppe. Thank you. Good morning, good afternoon, good evening to everyone. Let's discuss about ibwave solutions, which is dedicated for fiber optic technology, which is FiberPass. Next slide, please. So ibwave has been present in the telecoms business more than 17 years ago. This is a quick view on the list of customers that we have. So ranging from mobile network operators, from huge enterprise companies to vendors, systems integrators, and what have you. Next slide, please. So ibwave continuously innovate our solutions. No? So in the middle, you would see we're the only solution that brings it all together. We have a seamless indoor and outdoor survey and design solution, catering to multi-technology, including 5G. And of course, the one that we're discussing right now is fiber. And we are proud to say that our solution has the biggest list of having 37,500 parts of database of components on our database. And our ecosystems of partners, tech partners, systems integrators, vendors, OEMs, guarantees good access to market with high penetration rate. Next slide, please. So we're going to talk about FiberPass. It's a design tool for designing and maintenance solution for FTTX indoor, primarily for multi-dwelling units. Next slide, please. So this is our FiberPass solution offering, ranging from FiberPass Mobile, which is a field-based survey design. It's Android app. You can either install it in your Android tablet or in your smartphones. Again, it's Android-based. And our PC-based FiberPass design. It's a design and planning software suite. It's a desktop-based software. And overall, we have ibwave Unity. It's a hub. It's a collaboration platform, a project management platform at the same time. So what we now do in ours, what used to take days. So as you can see here, we're covering all of the MDU process, from the survey to design to approval, implementation or installation, up to the point of operations and maintenance. Next slide, please. Yeah, thank you. So this is the value proposition that ibwave FiberPass provides. We accelerate the FTTX deployment indoor. We create aesthetical and standardized documentation. The digitalization of your existing MDU and multi-tenant units, sites. We simplify maintenance and, importantly, for future upgrades and interoperability with your GIS and OSP tools. Next slide, please. So from here, I would like to give the table now to Justin to discuss about how the process works by using our solution.
Thank you, Carl. Good afternoon, everyone. Okay, so the entire Mdu life cycles, actually just like what Carl been explaining just now, is actually starting from site survey and design from the basic. Then we need to get the design to get finalized and get approved, both from building owner and also from the ISP. The next step will be implementations, and implementation will generate as built. And last but not least is actually operate and maintenance. So the entire process of here, from our traditional process, it might be very tedious, involving a lot of tools. So the traditional process, firstly, as for survey and design, will be much more focused on manual way. You're using pen and pencil, maybe Excel, and there might be, when we are actually doing all the design, there might be missing info, or misinformation is not tally between the design and the survey situation. And will involve a lot of other tools, will end up is actually quite difficult to do the entire survey and design together. So what ibwave provides? In current solution, ibwave actually have a Android applications which install on Android, which provide us have a wizard guided survey on the tablet itself. So last time when we actually do survey, we might take a lot of pictures, and at the end back to the office we need to reorganize the picture again, but most of the time we forget where we took the picture. So in ibwave, the guided wizard guided survey, it allows us not only to take a picture at a specific point, but also add in extra information. So extra information allow us to visualize where to install our equipments. Yeah, on top of this, we're able to easily point out where is the outdoor, where is the indoor, and how is the vertical, which is the riser. Be much more easy for us to engage the property manager by doing all the visualized effect. They're able to see it by their eye with the on-site report. We're able to generate a preliminary BOM. So all this information we able to immediate transfer back to the office to allow the designer to view the survey result immediately. So we're able to make on-site design decisions and able to meet about 80% of design completion when we are on site. And all of this will be digitalized, and electronical design will be sent back to the office immediately. And the designer in the office can immediately start the work. So the next phase will be how to finalize the entire design. So traditionally we need a lot of produce a lot of the information manually, such as the photo we taken on site, the information we taken on site. We need to redo it in the office again, reorganize in the office again. So it actually create a lot of hassle. So how about ibwave actually have another version called ibwave FiberPass PC version, which allow us to enrich the field data to bring design to 100% completion easily, and ensure design rules and KPI are satisfied between both network operator and also between the property manager. We're able to output the documentation to different documentation for what is network operator focus on, and another what is facilitator manager or property manager focus on. The next will be the approval process. So traditionally, the engineers or the surveyor need to applicate and all the engineering rules together into the process itself is actually quite complicated. Another one is about the KPI compliances, how we actually ensure the KPI compliances between the operator and also the building owner. So, and the property manager will receive a very little documentations, and it's a lot of to actually settle current requirements is actually quite difficult. So ibwave able to provide an automated KPI and engineering rules validations. We're able to send the report in a design file, but not only a PDF file. The design file will actually the design file able to view is ibwave viewer, which is free. So the property manager able to download it free and view the design file by itself, which is able to have much more clearer information. The property manager able to involve in the project in earlier stage to avoid any hiccups in between. Then we'll leave the schematic or visual with the property manager so that the property manager will have much more confidence in us. On the implementation stage, a lot of time when the design and the implementation might have some differences. So the documentation might be inconsistent because of a lot of updated versions. The as-built is actually lacking and deployment quality is very difficult to control. ibwave provides all this information have been designed and done in ibwave FiberPass in the PC version, able to transfer all the information back to Android version, back to the tablet version, which allow the person to install on site able to see clearly as what is required to install, where to install, and after he install, he can take a picture and save back into the tablet itself. So the documentation will always up to date and be very detailed. as-built will be done digitalized, and will able to validate the deployment quality. Last but not least is actually operate and maintenance. So traditional is the equipment, the hardware might not install on the right locations. We have difficulty to locate the equipment itself. Tracking the ONT, sometimes is, we care about a lot of unknown. The documentation is not up to date or lost in between from people to people. So ibwave solution is everything will be digitalized. So the as-built can be update anytime when we go to operate or we go to maintenance. We're able to see clearly what is the location required updated and what is the location or whether the equipment have enough port or not. We're able to track all ONT and we're able to access the site document 24/7. Yeah. So that's why ibwave able to help the process from days up to cut down to hours. Component database. So ibwave have the largest component database in the world. It consists of more than 37,000 components and growing every quarters. We have more than 320 equipment vendor update their equipment into our database quarterly. And it's not only have Corning products, they have other products as well. Yeah. Another one very important is ibwave Unity is actually a cloud solution and with the GIS interface. These solutions allow us to automate the deployment process. We're able to combine both MDU or MTU site data with the rest of your OSP infrastructure documentations. And also reduce the manual entry in various systems and reduce human error. So both of these products are able to help us combine multiple projects together and have a high level view. So next, I will actually pass back to Carl to actually explain how is the entire process and operation and how to cut down the process from days to hours.
Thank you very much. So as you can see here on this slide, on the black blocks, you can see from previous mode of operation compared to the new mode of operation. Previously, what they were using was like what Justin has mentioned. They use pens and paper notes, camera and pics, error prone. So what you do is from survey taking 2 to 3 hours, then go ahead with a high level design, takes about 5 to 15 days using Visio and CAD. So overall, again, 5 to 15 days. Plus you need to go and schedule a meeting with the number one, the service provider, number two, with the developer. Plus, once this is approved, you need to do the detailed design and upload it to the database, which would take about 7 to 10 days. Then you go to build. So you can just imagine the time consumed. Now, what we have here with our solution mentioned earlier, you can do the survey and high-level design using your ibwave FiberPass survey on the tablet, on the go, high-level designs, automated. which would take you about 2 to 3 hours. And provided that if you have a soft document stating that upon showing to the developer supervisor, this is where we're going. This is where we're going to put your ODFs, your cables, your clear tracks. So this is all where it is going. Then you can have an instant sign off to go and finalize the detailed design. It doesn't stop there. Right then and there, you can immediately upload on the cloud all your survey design and upload it to the database. Then have your finalization of the design done on the PC. As why? Because 80% of this design was done during the survey. So final design would take about 2 to 3 hours. So you can just imagine from 12 to 25 days, you can now do it from 4 to 6 hours with instant approval. Next slide, please. So these are just some examples on what was done with ibwave together with the major North American FTTH service provider together with their main FTTH contractor. Okay, so as you can see here, 4 different project sites. One is 3 floors with about 143 units, 5 floors with about 56 units, 2 floors with about 12 units, and 2 floors with about 10 units. For the survey and high-level design, just took about 3 hours, 2 hours, 1.5 hours, 0.75 hours. For the detailed design, meaning using the PC-based ibwave FiberPass PC, it took them just an additional 1 hour and 30 minutes, 3 hours and 15 minutes, 0.5 hours, and 1 hour and 15 minutes. What if your designer is also together with you using his laptop? It will be much more faster. So the materials and build of materials creation are all automated. You can have a 3D modeling as an optional. The 3D modeling would not only be viewed by you, by the mobile network operator or by the FTTH service provider who has a copy of the license, but like what Justin has mentioned, they can all download the free ibwave viewer and they can view the project in detail also in 3D. So from the previous survey and design, it took them about 12 to 25 days in average. So you can see with FiberPass, it just takes them about 4.5 hours, 5 hours and 45 minutes to the max. Next slide, please. So this is a clear view on what FiberPass provides as benefits and FiberPass's advantages. On the advantages, it's faster survey and design. It's quick and efficient projects turnaround, on-the-fly design iterations. No need to rescheduling. So it's visually rich, easy to read design packages. It's standardized digital design and documentation, standardized GIS interface. The benefits, it's very obvious. Time and cost savings. The faster property management sign-off, like the one I showed you a while ago. Quick technical approvals and validation. We automate the process with easy integration of existing platforms. We connect new customers smoothly and efficiently from having all your designs done in hours. So we digitalize your MDU and MTU deployments and operations. Next slide, please.
Yep. This is the last of the slide. Thank you, Carl. And
Thank you.
We would like to pass this to Raj.
Thank you, Justin and Carl. It was a really beneficial presentation. So now we will move to the Q&A session. To all the audience, If you have any queries or questions, you can just go to the questions panel and ask your question there. So let me just take some of the questions from the question panel. Okay, so the first question is to Ariel's presentation. So the question would be, how many units can a team install in one day? Do you have a suitable answer for that? Ariel?
Hello? Yeah. Yeah, so for hallway, actually, we can do up to 7 to 10 units per team per day. So per team meaning either a 1-man team or a 2-man team. Yeah, so that's how fast it is.
Okay, that's good. So the next question is the 12F micromodule and 900 clear fiber available in multimode?
Okay, so right now, this was designed actually to support the FTTH deployment. So it is only available in a single mode version. Thank you.
That's good. Okay, so the next question is Sudipta Bhaumik from India. His question is to Ariel as well. Is the 900 micron fiber and the installation accessories fire safety rated for in-home application?
Yes, so the technology as well as the manufacturing is out of US. So this is actually it has certification from UL as well as ASTM, signifying that this is for indoor application, and it passed the indoor requirements for communication circuit. Thank you.
Okay, that's good. So the next question would be from Raj Matai. His question is for new MDUs, the fiber cables already pre-installed or only the ducts are installed for pulling the fiber cable later?
Yeah, so actually, this clear track fiber pathway was was not actually designed only for brownfield MDU, but also for greenfield MDU. So right now we are doing a lot of buildings already, and we are surprised that even a greenfield MDU would like to actually to use also this clear track fiber pathway, because maybe during the construction or the design of the building, they did not consider routing a fiber cable or incorporating fiber cable routing into the design. So we are right now installing clear track for greenfield MDU as well. Bulk is actually on the brownfield MDU.
Okay, that's good. I think that answers the question. So, and I am not finding any other questions in the question box. So I think today we can conclude the session here. So before we conclude, we would like to let you know about our next webinar, which is on November 30th. It will be on 5G fronthaul evolution, fiber and transport test diversification challenges. So the registration link and details will be shared with everyone who attended today here shortly after the session finishes. And I'd like to thank all the audience, especially to all the speakers who have had a great session today here. Ariel, Carl, and Justin. Really thanks to you. So with this, I'd like to conclude today's session. I think I hope everyone stays safe and stay fine in their workplace and so on. Thank you, everyone.
Thank you, everyone.
Thank you, everyone.
Thank you very much.
Thank you.